Welcome to day 65, 7.4 arc length. So we need to talk about, well, what is arc length? Okay, so arc length is approximated by straight line segments whose length are given by the distance formula. So if we're looking at this curve over here, we essentially want to find the length of this arc. Okay, and we're going to do that by piecing all these different straight lengths together, and eventually what's going to happen is we're going to create these lengths so that the distance between these x values is smaller, smaller, smaller to an infinite amount, and that will give us our smooth curve, and we'll be able to find the length of that. Okay, so first we can go ahead and say that our arc length is S, okay, and it's equal to the length of the curve from A to B. All right, so let's get into figuring out what the formula is. So as I mentioned, it's the distance or the length of all these pieces using that distance formula, and eventually we'll make these pieces smaller and smaller and smaller to get that nice curve to it. Okay, so looking at our distance formula, let's just suppose we're picking this point xi here, okay, xi, yi, and then xi minus 1, yi minus 1. So we're finding the distance between those 2 points. All right, remember it's the difference between your x values squared plus the difference between your y values squared, and we're taking the square root of that. Well, let's let delta x be that difference, that xi minus 1. Okay, so if you're looking at our diagram, we're letting this distance or the difference between those, that's our delta x. Okay, which means then our delta y is going to be that piece of the curve. That's our delta y. Okay, so our delta y is going to be the difference in the y values. So our arc length, we're essentially just adding up all of these distances. Okay, we're adding up all of these little pieces. So let's zoom in here and just see where we get that formula from. All right, so it's the sum of all those distances that we're adding together, and that's going to give us our arc length. Well, if we factor out a delta xi squared, okay, we're going to get the square root of 1 plus delta yi squared over delta xi squared, and then times delta xi squared. All right, well, one thing that we kind of need to note moving over to the side really quickly is that because f prime exists for each x, so the derivative exists, the mean value theorem guarantees existence of some value c within that interval. Okay, so remember that aspect. So we can go ahead and say that f prime of ci is really delta yi over delta xy. So that's that slope, right? Okay. It's the slope between those guys. So we can then move back over here, and instead of delta yi squared over delta xi squared, we've got f prime of this ci squared. Okay? Taking the square root of delta xi squared, we're just left with delta xi on the outside of our square root. Now, remember, if we let n go to infinity, so there's an infinite amount of these little pieces that we're adding up, these intervals, then that tells us that our partition, the biggest interval, is going to 0. Okay, so that's going to allow us to get that nice curve, being able to find the length of that curve. So we're going to take the limit as that partition goes to 0, which means n is going to infinity, okay, of all of these summations, right, of all these different lengths. All right, so that leads us into our arc length formula. So we're going to let arc length be s. It's equal to the integral from a to b of the square root of 1 plus f prime squared dx, or if we're talking about it in terms of y, it's the integral from c to d of the square root of 1 plus f prime of y squared dy. So then just going back over to our diagram here, we've got this rectified curve has a finite arc length. We're allowed to say that. We can find the arc length of this. The condition is f prime has to be continuous, and therefore, if f prime is continuous, then f is continuously differentiable on the closed interval a to b. All right, so that's going to allow us to find the arc length there. So let's go ahead and jump to our first example. We want to find the length of the arc of f of x, or on f of x, between the points 8, 2 and 27, 17 for our function f. So in order to do this, we're using our formula. We need f prime. All right, so that's the first thing I'm going to do is I'm going to figure out what f prime is. So f prime is going to be 2x to the negative 1/3. So f prime squared, because we'll need that for our formula for arc length, is going to be 4x to the negative 2/3, or we can write it as 4 over x to the 2/3. Plugging it into our formula, we are now going to take the integral from 8 to 27, because those are our x values that we're between, of the square root of 1 plus 4 over x to the 2/3 dx. And now it's just a matter of cleaning things up. So getting common denominators, multiplying this guy by x to the 2/3 over x to the 2/3 is going to allow us now to rewrite what's underneath. Then we can take the square root of that denominator, which will bring an x to the negative 1 over 3 to the outside, times the square root of x to the 2/3 plus 4. Now we need to use substitution, which works out very nicely. Taking the derivative of what's underneath that radical, we get 2/3 x to the negative 1/3 dx. So we can make sure we bring out the 3/2 in front of our integral from a to b of u to the 1/2. Now we can integrate this pretty easily, and hopefully you guys can follow along on your own. But in the end, after we make our substitution back and evaluate it from 8 to 27, we're going to get our exact answer of 13 to the 3/2 minus 8 to the 3/2, and that is the length of the arc. Okay, I want you to try this example too on your own, or at least kind of piece by piece. So find the length of the arc of f on f of x between x equals 2 and x equals 5 for the function y equals x to the 5th over 10 plus 1 over 6x cubed. My hint here, so that we can easily find the derivative, is to rewrite y. So it's x to the 5th over 10 plus x to the negative 3 over 6. So the first thing I want you to do is find the derivative and then square it. And then once you do that, check before we set up our integral. Okay, so hopefully you got y prime to be 1/2 x to the 4th minus 1/2 x to the negative 4th, which cleans up to be x to the 4th over 2 minus 1 over 2 x to the 4th. Getting common denominators and kind of cleaning this up, I needed to multiply this guy by x to the 4th over x to the 4th, and that's where we get y prime to be x to the 8th minus 1 over 2x to the 4th. Squaring that and cleaning it up a little nicer, you get x to the 16th minus 2x to the 8th plus 1 all over 4x to the 8th. Okay, so now I want you to go ahead and set up your arc length integral and see if you can work through it. And I might give you a little hint and stop you to continue. Okay, so we know arc length is equal to the integral, and this is going to go from 2 to 5, of the square root of 1 plus y prime squared. Well, we know what y prime squared is, so just substituting that in. Getting common denominators and cleaning up underneath our radical, we're going to get 4x to the 8th plus x to the 16th minus 2x to the 8th plus 1, and we can combine those nicely to ultimately get the integral from 2 to 5 of the square root of x to the 16th plus 2x to the 8th plus 1 all over 4x to the 8th. All right, so what we can do is if you factor the numerator, okay, you should get a perfect square, which cleans up. So I'm going to leave it to you, see if you can take it from there and check back when you're done. All right, so, so factoring the numerator underneath the radical, And we can rewrite the denominator to be a perfect square so that when we take the square root of it, it works out nicely. We're ending up with the integral from 2 to 5 of x to the 8th plus 1 over 2x to the 4th. And we can split this up to be the integral from 2 to 5 of 1/2 x to the 4th plus 1/2 x to the negative 4 dx. And this now we can integrate hopefully pretty easily at this stage. So hopefully you can take it from there, check my work. Okay, as you do integrate and evaluate, eventually you will get your answer of 618,639 over 2,000, and that's approximately 309.319 or 309.320. Remember, on the AP exam, we're going to round to 3 decimals. You can either cut it off after the 3rd decimal or you can round accordingly. If you have any questions on arc length, let me know.